Hey, everybody. Happy Friday. Hopefully, the test went well for you yesterday. I'm actually recording this yesterday on Thursday, so I don't know how everybody did, but I saw some of the scores coming in, and there's some pretty good scores out there. So hopefully, yours is one of those. We are moving on to our last chapter of the year today. We've only got a couple weeks left, and so we only have time for one more chapter, and that focus of that chapter is going to be circles. I don't know if you've been keeping up on all the information coming out about the end of the year, but one thing that is probably important to know is that at least in this class, you will not have a final exam. I know some classes need to give finals because they're college classes and required for other different things, but at least for this class, I wanted to let you know that we will have one more test over circles, but there will be no final exam. So um, I guess probably for most of you, that's pretty good news. Um, the bad news about this lesson, I guess just this lesson, is that because it's the first day of a new chapter, it's going to be a lot of notes, a lot of new terms and stuff like that. And you're probably thinking, well, Mr. Crowett, I know what a circle is, but we're going to be dissecting and taking circles and looking at lots of different properties and parts of them that maybe you don't know about. Some things you will, some things will probably be new for you. The good news is that because today's focus is going to just be on notes and terms, you also won't have a homework assignment over the weekend. So, again, that's probably good news for you, but that is where we are. So, let's just dive right in. We'll get through some new terms and definitions for circles. First of all, the definition of a circle, and this is something that came up um, previously, back when we were actually in the same room with each other when I was trying to teach you, and that is a circle is a set of all points in a plane that are the same distance away from a given point, which seems like a long definition. Isn't a circle just something that's round? But what does round mean? And so when we have this definition, a circle is a set of all points, every single one of these points, not even just the ones that I have labeled, like point G and point B and point D. Yes, all of these, but then all of these points that are in between, everything that makes this a circle, each one of these is the same distance away from the center. The distance, the length of that segment is the same as the length of that segment, and it's also the same as the length of this segment that goes out to the circle. I'll name a circle by its center, especially if there's more than one circle. In the case of this one, obviously it's the circle, but I could also refer to this as circle A, or sometimes you'll see, whoops, that doesn't work. Sometimes you'll see it written out as they'll use this symbol to represent a circle, just a literal circle with a dot in the middle of it, and that would mean circle A. A couple terms that we have seen before, one of them is radius. Of course, you guys know what a radius is. I'll make my radius blue here. The radius of a circle is a segment that goes from the center and extends to a point that's on the edge of a circle. Again, we've certainly seen this before. I'll usually use a lowercase letter r to stand for that. An example of a radius in this diagram is the one that I just drew, segment AC. And man, this goes back to September, remembering that that's the way we show that something is a segment. Something that we haven't seen, and I'll do this in red, is a chord. A chord goes from one point on a circle, and it's a segment that goes to another point that is on that circle. This is just one example. Of course, there's a lot of different ones that I could draw. Um, B, E, F, D, G, D, B, E, I think I maybe said already, but the one that I've got drawn on this diagram is segment ED, and segment ED is just one of the many chords on this circle. Another term that you have seen before is diameter. I'll do this one in blue. A diameter of a circle is a segment that goes from one point on a circle through another point. So it is a chord, but it's a chord that also goes through the center of the circle. And so there we go. In the case of this one, segment FC is a diameter, again, because it goes through the center of the circle. And then an arc, you've probably seen that word before, but in geometry, the word arc means an unbroken part of a circle. So I'm going to draw this unbroken part. So far, I've drawn arc GB, I'm going to go a little bit past that to show you that it can go past one of the points that's labeled and all the way down to that. And the way that I represent arc GC is, of course, with the 2 letters, and you might be able to guess this. Instead of a segment up on top, I'm going to put a curved symbol to show that this is arc GC, and it says that it's an arc that goes from point G to point C, like I've got drawn on the diagram. If we choose any 2 points on a circle, we divide that circle into 2 different arcs. Now, what I mean by that, I'm actually going to go down here to the minor and major arc. What I mean by that is if I draw this arc GC, that takes care of part of the circle. So this would be minor arc GC. But then there's another arc GC that goes from point G to point C. I'll try to do this as neatly as I can. This is more tricky with a mouse than it is with a pen. But actually, aside from that one little lump, I've been doing pretty well with this so far. There we go. And so arc GC, the way I've got it written up on the top, arc GC would be written like that. And it's important that we can distinguish between the minor arc GC and the major arc GC. And one way that we can do that is to say, yes, it starts at point G and it ends at point C, but it also goes through point F. And so if I say GFC, that's saying that it's an arc that goes from G to C, but it doesn't take the short way. It goes the long way around and goes through point F. Or I could have used point E here, or I could have used point D as well. So the minor arc is the short one. It's less than the semicircle, which is a term I'll define in just a second here. And then the major arc is the other part of the circle that is larger than a semicircle. In a semicircle, let's see, I might actually just copy this slide and make a new one. The semicircle, I am going to erase this part of that arc. I'm going to erase these two. A semicircle is an arc whose endpoints lie on a diameter. So 2 slides ago, we saw that FC is a diameter of this circle. And so if I say arc FC, that could be going this way or it could be going the other way, but it doesn't really matter because if this is a diameter, then it cuts it right in half, which means arc FC, the red one that I've got drawn here, and arc FC down here, the blue one, those would be the same thing, or at least they would have the same length. That's a semicircle. It's half of the circle. All right. Again, I'm throwing a lot of terms at you, but if you're writing these down in your notebook, and you probably should write them down in your notebook if you're not doing it already, I'll just keep going and you can pause the video if you need to pause and write these things down. Moving along, central angle. I'm going to switch over to my segment tool so I can draw these more efficiently. A central angle is an angle where the vertex is at the center of a circle. So here would be an angle, a central angle. Angle CAD is a central angle. And I can draw this, of course, as angle CAD. I definitely can't just call it angle A because there's a whole bunch of different angle A's that I could draw, but angle CAD is the one specifically that I've got drawn here. And then the intercepted arc, oops, I didn't mean to push that. The intercepted arc, in this case of angle CAD, is arc CD. And we'll be talking a lot about these angles versus these arcs. Angle CAD, we could measure that with a protractor, but arc CD, well, we can measure the length of that, but it's hard to measure the length of something curved like this with a ruler. If the distance straight from C to D is 3 inches, well, then the distance from C to D along this arc would be a little bit more than that. And so that's one of the big things that we're going to be talking about in this chapter. Or we may measure this arc, instead of measuring it by a length, we may measure it also by an angle measure. And conveniently, if I measure this angle, if I measure this arc CD in terms of an angle, it's exactly the same angle as this central angle that corresponds with it. And so if this is a 52-degree angle, if I took a protractor and measured this angle to be a 52-degree angle, that means that this arc would have a measure of 52 degrees also. And so when I refer to the measure of an arc, I'm usually going to refer to it as this corresponding central angle. And so all the way around a circle, that arc would measure 360 degrees. Again, all the way around a circle, an arc that goes all the way around the circle would be 360 degrees. And then the last new term for us today is an inscribed angle. This is different from a central angle in that the vertex isn't at the center of the circle, but it's actually somewhere on the other side of the circle. So 3 points that are on a circle, one of them is the vertex, and the other 2 are determining where those rays are pointed on that angle. And so this is an inscribed angle, again, because the vertex is on the circle. And what is interesting about this is that if arc CD measures 52 degrees, then arc CGD, this inscribed angle, the measure of this angle turns out to be exactly half of the measure of that intercepted arc. And here I've got a different diagram. Actually, it's the same diagram, but now the inscribed angle has a different vertex. Instead of a vertex at point G, the vertex is down here at point E. But it doesn't matter to the size of this angle. The measure of this angle will be equal to exactly half of whatever this intercepted arc is. And you can see on the diagram, it looks like it should be the same, and it is the same. This angle right here, angle CGD, is the same as angle CED, as long as G and E are both on the circle, and that 26 degrees comes from exactly half of the intercepted arc. And so there we go, a whole bunch of terms. Definitions. You may have to watch this video twice because I did go fairly quickly through this to make sure that you understand what these things are. On Monday, we'll come back and take a look at some problems and actually solve for angle measures and things like that. But I'm going to save that for Monday. You guys have worked hard enough getting ready for the test that you took yesterday. So hopefully you have a great weekend, and I will see you on Monday. Bye-bye.